Okay, whereas the bolt represented by the pitch control managed to maintain a constant active power until just before the cut-out wind speed is met. Mhm. So it is seen that to keep the TSR constant at its desired value, it is necessary to control the turbine rotational speed omega in proportion to the wind speed V. Alternatively, a turbine can be operated at one of the two fixed rotational speed, which gives a TSR closer to the optimal than a single fixed speed, but is slightly less efficient. So as I mentioned just now, right? We want to maintain TSR at a particular value that gives us an ideal CP value. But of course, if you want to control TSR, then you have to consider the rotational speed and also the wind velocity that you are currently facing. So wind variable speed control is more expensive than a fixed speed control, of course, because variable speed control requires more actions and more intelligence operation, but it's found to yield 20 to 30% more energy, as you can observe also from this curve. The pitch control, the active pitch control by the bolt line is more efficient than the dotted stop control. So the additional expense of variable speed control arises from the need for a controlled and variable pitch propeller, and also from the need for a power electronic frequency controller between the variable frequency generator output and the fixed frequency bus bar of the load system. So as I said just now, the variable speed control is a more sophisticated operation that requires more intelligence in the systems. And also because we are constantly changing the pitch angle, we also need a certain power electronic setup to make sure that the connections of the wind power or the wind voltage frequency is similar to the electrical grid frequency. Okay. These are the comparisons between fixed speed and the variable speed control of the wind turbine that you can go through yourself. So, this is the final slide. So turbine efficiency, just now from this slide, right? From this slide, turbine efficiency is given to us by the ratio between the output and the input, isn't it? And the gearbox efficiency is given to us by the ratio between PG and PX. And the efficiency of the generator is given to us by PE and PG. This is quite self-explanatory. So this is what is mentioned over here. Turbine efficiency is given by the output over input, the ratio. The gearbox efficiency is the output over input, PG over PX. And the generator efficiency is PE over PG, the output over the input, the efficiency. Okay, so if you want to calculate the total efficiency, then you take this, multiply this, as such. And if you put everything together, if you compare the efficiency between the electric power and also the wind power, then the electric power is equals to all this, okay? The efficiency in between the systems multiply the wind power. So wind power given to us as this. This is a theoretical maximum wind power offered by the incoming wind. And these are the values, the typical values, depending on the size of the machines for the CP values. And these are the efficiency, depending on the size of the machine as well. And these are all typical values that we normally witness in the industry. So with that, I have finished the lectures on wind turbine, and you can expect one quiz, if I'm not mistaken, or one assignment from me. Anyway, in any case, keep an eye on e-learning, and I will make announcement on e-learning, and notice on all the things that I'm going to upload on e-learning. I will upload all these videos on e-learning. Of course, if you are seeing this, then meaning that you have downloaded the videos, and I will also upload the lecture slides on e-learning. One important note is to please pay attention to the assignment or quiz. I'm not sure. I need to check that I will be uploading on e-learning. Okay, I will make sure that you know.